Hi, good afternoon. Thank you everyone for your time. My name is Jeff Fang, and I'm a product manager here at Tableau Software. I am super excited to be here today. Vish and the Google team have invited me here to speak because of the cool integration we've built with BigQuery. If you are a big data geek like me, a tool like BigQuery plus Tableau is like giving a 16-year-old teenager the keys to a brand new Ferrari. Hopefully I can drive this Ferrari better than a teenage driver can. Today, I'll tell you a little bit more about Tableau, our integration with BigQuery, and we'll build a cool viz together using GDELT, the largest events database in the world. Tableau's mission is to help people see and understand their data. This has been Tableau's mission statement since day one, when Tableau started over 10 years ago, and it's still our mission statement today. We strive to make our products work for the typical business user. That's how I discovered Tableau. I was a business consultant at McKinsey, where I spent many late nights mining beneath the surface of data, not very effectively. I was using pivot tables, and pivots of pivots, and pivots of pivots of pivots. Tableau was the tool I needed to help explore my data quickly and focus on answering the questions I had, rather than the process of answering questions. At Tableau, we have four main products: Tableau Desktop, our main authoring tool and flagship product; Tableau Server, our main collaboration tool; Tableau Online, a Tableau-hosted version of Tableau Server; and Tableau Public, our free offering targeting everyday data enthusiasts and journalists. Today I'll be demoing Tableau Desktop. Here's a quick overview of our product. A user connects their data either live to the source, or an extract can be brought into Tableau's in-memory data engine. Dimensions and measures are automatically detected on the left-hand side based on their data type, where they can be dragged and dropped either onto the main canvas window or onto one of the corresponding shelves, such as the filter shelf, the marks card, or the column and rows shelf. The software interprets your actions and applies visual best practices to create data mashups. Tableau plus BigQuery is a powerful combination. Together, you can analyze massive amounts of data using simple drag and drop operations. A few quick highlights here. First, Tableau added native BigQuery integration starting in Tableau 8.0. It was completely rewritten from the ground up in 8.2. Originally, we leveraged an ODBC connector that translated SQL queries into BigQuery API calls. Now we directly write BigQuery queries directly to the service using the web APIs. It was also optimized for performance. The connector parallelizes BigQuery queries to make responses even faster. This is the Ferrari you always wanted as a 16-year-old. Secondly, with our native connector, Tableau provides live connectivity in BigQuery. This feature allows you to keep your data assets where they are. It also enables you to keep up with real-time changes to your database as the data gets updated. Third, you don't need to write complex SQL. Tableau takes on the challenge of writing syntactically correct BigQuery queries based on your actions in Tableau. Lastly, Tableau plus BigQuery enables users to perform visual analytics at internet scale with no new additional infrastructure. Let me show you the Ferrari in action with a test drive. But before I do that, let me first tell you about the dataset. GDELT is a global public dataset that monitors the world's broadcast, print, and web news from around the world. It catalogs human society behavior at scale across all the countries of the world, connecting every person, organization, location, theme, and news source and event across the planet. It also provides context as to who is involved and how the world is feeling about it every single day. GDELT pushes the boundaries of big data with over 250 million records, 60 fields per record, nearly 400 million latitude and longitude geographic coordinates, and covering a time span of more than 35 years of human history. In short, it is the largest open access database on human society in existence. So let's dive into the demo with the following question in mind. How can GDELT help explain the impact that news and media has had on historic events? And so what I've done here is I've created a blank workbook, except that I've connected two translation data sources, which help to translate text event codes into, numeric event codes into text strings. We start by connecting to the BigQuery service. On the left-hand side here is a list of the connectors we provide in our Mac product, and I'm demoing our Mac product today. So I log in with my credentials. After I click Accept, I'll be presented with our data connection window. Here I can select our data set. And I'm going to pick the event set here. Now, in our visual connection experience, it allows us to visually see how we want to merge our data sets. So for instance, if I want to connect this other data set here on Crosswalk, I simply drag it over to the window here, and it will give me a list of options as to how I want to connect our data, whether I use an inner join or a left join, as well as the text field that we join on. In this particular instance, I'm not going to join the data, so I'm just going to click back and just look at our events data set. Down below, it gives us a preview of a schema of the data set we're connecting to, and if I'm happy with it, I click Go to Worksheet. Now, this is our first blank canvas. Let's first display the number of records. Double-click here. And we see that there are over 270 million records in this data set. Great. Now we can begin asking questions of our data, such as how does the number of records and events vary over time? So I double-click on year, and voila, there we have it. Let me change this to an area chart. And the interesting thing that we see here is that the growth of the number of records is nearly exponential, starting from about 1994. I believe that this can be attributed to the growth of the internet and social media. Now let's take a double click into our data from this point. Let's say instead of looking at number of records, let's look at number of articles. Now the difference between number of records and number of articles is that each record represents one event, but each event can have multiple articles that reference it. So what I'll do is I'll swap out number of articles and number of records. And there you go. And now let's cut the data into different categories of events and articles. So what I'll do is I will, we've brought in this other data set called quad class codes, which essentially provides a translation for these numeric event codes. Right now it's classified as measure, so I'll bring it up as a dimension. Then we are shown this link icon. Once we click on it, it links the two data sets together so that we can perform a data blend. Now I'll grab quad class translation and bring it on to the color tab. And there we have it. Look how easily Tableau is able to perform a data blend on this large data set. Now also grab quad class translation and drag it onto the label shelf. And there we go. We've created our first viz on articles versus time. Now let's take a more in-depth look at the root causes for events. So now I'll grab the number of articles, drag it onto the row shelf, and let's look at it versus event root code, which is a subset of the quad class code. We do a sort, and let's change the axis, and there we have it. We have the number of articles as a function of the event root code. Now, as mentioned earlier, the event root code in the GDELT dataset is not very intuitive. So therefore, I've brought in the event root code set here. And notice that it's already linked. All I need to do is drag this onto the label shelf, and we're provided with more in-depth labels as to what each of these articles are classified as. Since we no longer need these, I can just hide the header. And there you have it. Now let's say I also want to classify these into different groups of the quad class codes. I simply go over to here, link the data, and drag it onto color. Now we've produced a data blend on 3 different data sets. Great. Now let's look at this in terms of geography. I go back to our events data. I will take actor 1 country code, which is the primary actor for each of these events and articles. And I will also grab the number of articles and bring it to the column shelf. Now I'm going to show the Show Me feature, which allows me to visually see what are the different types of visualizations I can look at with given the data that I have in play. Here I'm going to select the symbol map. And let's increase the size. And to make things easier to see, I'm going to turn on some color effects. And there we go. What I'm currently showing is a summation of all the articles by geography for each country. Now let's say that we want to bring another piece of data in. Let's say we want to bring in tone. Now what we do have is the Goldstein scale, which is a measure of tone and overall stability that an event brings to a particular country. It's measured on a scale from -10 to +10, and so I'm going to bring it here onto color. And I should mention 10 as being like a very positive event, whereas -10 is a very negative event. Now the default is that it brings it in as a sum, but what we really want is an average. Awesome. Now let's say we want to bring another parameter to play. Let's say we want to look at this over time. I can drag year onto the page itself. And what this will allow me to do is to step through over time and look at how the events have varied versus intensity as well as tone over time. I click play, and we can watch it here. Now, one thing, I'm not sure if you caught it, but one thing you would have noticed is that there was a flare-up in the Middle East in terms of the number of articles and a reddish color, which represents negative tone. We'll dive more into that later. Now what we're going to do is we're going to create our first dashboard. So before I do that, I'm going to grab year and drag it to the filter shelf because I want to have that as an available parameter. So what I'll do is I'll grab the intensity map, I'll bring in articles versus time, and our events root cause bar chart. Let me adjust the sizing here. And we can even add interactivity by using each chart as a filter for the other charts. That way, when I click on one country, it'll update the other charts. What I can also see here is that by hovering over the US, we get a tooltip which shows the average Goldstein scale and the number of articles. And there we have it. So now what I've done is I've taken the visualizations we've built and I've given it a little additional love, and I've also done some additional analysis to create a story point. So storytelling is one of the new features that we've added in 8.2, and I'm going to show that here. So let's start with our story. First, media has grown exponentially over the last 20 years, and this has largely been an effect of the internet on news and media articles. Here's how the tone and intensity have varied over time in geography. And we can rewatch this cool viz now. Notice the flare up around here. Using Tableau and BigQuery, we can ask questions of our data, such as, well, what do these charts look like in terms of articles versus time and event root cause for the US? We can also ask questions such as, what happened during the Arab Spring? Now, this particular article is by data analysts who use the GDELT data set to analyze the effects of news and media events or news and media articles based on different events. I've taken a similar approach and looked at the articles and tone for the countries of Tunisia, Egypt, Libya, and Yemen, the 4 countries that had an overturn in leadership as a result of the protests. Now, if you remember your history, you'll remember that the Arab Spring began in December of 2010. The protests and demonstrations were very intense and sustained. So you can see that there were a number of articles that occurred even after there was an overturn in leadership. I believe that the internet and social media were main means used to effectively spread information and promote the movement. But what about Tiananmen Square? The coverage around Tiananmen Square was very intense but short-lived. I believe there are a few reasons for this. First, because the event took place in 1989, there was no internet and social media to help spread the communication. The Chinese government also had a strong government control over the news and media. In fact, even after the protests, they banned foreign journalists from being in the country. Lastly, they used military power to quickly stop the protests, and as you can see here, the articles returned back to normal soon after the protest. So in summary, Tableau plus Google are better together. Tableau provides live connectivity to Google's BigQuery service, and by doing so, we help to leverage the power of Google's cloud. It is also very fast. As you saw, we were able to analyze billions of rows within a matter of seconds. This helps to accelerate the time to insight from weeks and months to literally seconds and minutes. And lastly, it allows you to, it's easy to use by any user and any organization. You can ask and answer any question you have without doing any coding. So thank you very much for your time, and I hope you enjoyed the ride.